This is class 35 of my arithmetic course. Today we're going to learn multi-step word problems. Most of the word problems that we've done in this course so far are one-step word problems because this is a beginning course, and the purpose of the course is to teach you the basic algorithms for addition, subtraction, multiplication, and division of whole numbers, decimals, and fractions. The purpose of the course is not to try to give you a lot of tricky word problems, but you are going to need to learn multi-step word problems because most of the word problems you do on tests in school or tests that you may take outside of school are going to have multiple steps. Now, I want you to understand very clearly that there's an infinite number of word problems out there at this math level. There are people that are paid to make new word problems every day. So it's impossible to teach you every single type of word problem. You could develop an entire course just teaching word problems. In fact, you could develop 10 courses just teaching the different types of word problems. So we're not going to, I don't want you to get the false impression that after this class, you're going to know every type of word problem. We're just going to cover a few word problems in this course, and the purpose is to get the juices in your brain flowing and to raise your confidence level so that when you see multi-step word problems, you won't just give up immediately. You'll have at least some confidence to attempt those word problems. So in this class, we're going to do 10 word problems. We're not going to do, 50 or 60 or 70. We're just doing 10. That's it. And the reason that I'm only giving you 10 is that it's generally true when it comes to math and probably just about anything in life, is that it's better to teach you a small amount of material and guarantee that you master it rather than teach you too much material and guarantee that you master none of it. So we're just going to do 10 problems. I also want you to be aware that some of these problems are pretty intimidating. They're not difficult, but they can be pretty intimidating, and even high school students would have trouble with some of these problems. And I chose those problems on purpose because I want to raise your confidence level and show that you can do problems that are fairly intimidating. And that's the whole point of this class is, again, to get the juices in your brain flowing and to get you psychologically prepared for some of the more difficult word problems. But as you probably found out, doing some of the word problems in this course, word problems are 1,000 times more intimidating than your basic algorithm problems, because word problems, unlike algorithm problems, actually require you to think about what you're doing. So as we go through this class, you may start to become worried or intimidated, and you may start to become anxious because you're not understanding every single step or all the concepts in these problems. But I want you to constantly remind yourself through this class that we're only doing 10 problems. That's it. I'm going to require you to know how to do these 10 problems. Even if you don't understand all the concepts, just learn how to do them. And then after you learn how to do them, you can go back and figure out the concepts that you don't understand. But just because you don't understand the concepts doesn't give you an excuse to not learn these problems. To be honest with you, when students are doing really hard problems, most of the time, high school students and even college students, they'll do the problem and they'll get the right answer without even understanding necessarily why the algorithm works that they used. And they'll get an A on the test, even though they may not have understood every single concept. So again, just because you don't understand every single concept in these problems does not give you an excuse to give up. I require you to know how to do the problem. So again, constantly remind yourself there are only 10 problems, figure out how to do them, and get them done. And if you feel, again, I know I'm repeating myself here, but I want to be absolutely sure that you understand. If you start to feel that these problems are much more difficult and you're getting kind of depressed because you're not understanding everything, don't be depressed. That's completely normal. Middle school students, high school students, students that are taking upper courses, they all feel that way when they're doing word problems. because word problems are way more challenging than your typical algorithm problems. So that's all normal. But again, there are only 10 problems. That's it. Only 10 that I'm requiring you to know. Learn the 10, get them done, don't complain, and get the homework done, and let's go on to the next class. So that's the goal for this class. So with that said, let's get started. As I explained, there are 10 types of problems, but we're not going to just do 10 problems today. So I have 4 versions of each problem. So we have problem number 1, I have 4 versions, and then we have problem number 2, I have 4 versions, and so on and so forth. So let's do problem number 1, and we're doing 1A. Let me get rid of this highlighter here. So 1A is a geometry problem. So it requires you to know what a square is and what perimeter is and what area is. Those are all things that I require you to know. A square has perimeter of 24. What is its area? So this is a square. And we'll just say that these are the sides. We don't know what the sides are. In order to find the area, we have to take the width and multiply it by the length. We learned that in previous classes. That's just the definition of area. You need to know how to find the area of a rectangle and a square. So area equals S times S. But the problem is we don't know what S is. But if we know it's a square and all the sides are the same, and we know the perimeter, the sum of all the sides is 24. So P equals S plus S plus S plus S, and we know that equals 24. We can use this information to find how long each side is. So what number multiplied by 4 equals 24? In other words, what number do you add up 4 times to get 24? Well, obviously, it's 6. You can use your multiplication facts to figure that out. So now we know the area is 6 times 6, which is 36, and you're done. So that problem wasn't too bad. Now, if you didn't understand that, that's okay. We're going to do one more problem before you try one on your own. So again, you need to know what a square is. You need to know that the side lengths are all the same. You need to know what perimeter is. That's the sum of all the sides. And you need to know how to find the area of a square. It's very typical for word problems to have a lot of geometry in them. So I'm just requiring you to know the basic geometric principles. All right, let's go on to 1B. A square has an area of 64 square meters. What is its perimeter? So this problem is going in the reverse direction. In the previous problem, they gave us the perimeter, and they asked for the area. In this problem, they give us the area, and we're asked to find the perimeter. So let's draw our square here. Same situation. All the side lengths are the same. And we want to find its perimeter, which is the sum of all the sides, but we can't find the perimeter because we don't have the side lengths. But we do have the area, so we know that the area is equal to the length times the width, and that is equal to 64. So now we ask ourselves, what number times itself is equal to 64? And if you know your multiplication facts, you know 8 times 8 is 64. So the side length is 8 meters. Now notice in the previous problem we didn't have any units. It was just 24. But in this problem we have square meters, which means that our side length is going to be in meters. That's where the m comes from there. So now we know the side length, so we can find the perimeter. We just plug in the 8. And 8 added 4 times is just 8 times 4. You should know that from your multiplication facts. That would be 32 meters. All right, so why don't you try 1C, and I'm going to leave these two problems in the in your view here, so you can use the previous two problems to do 1C. And remember, these are new problems. Multi-step word problems, they always feel new. These problems are much different than the problems that we've done in the past. So if you feel like they're different, that's completely normal. Just use the previous problems, and when you're done, we'll do 1C together. Pause the video. All right, we're back. A square has perimeter 12. What is its area? Whoops, forgot to put a T there. So again, we have a square. I'll just rewrite that. And we want to find the area, which is S times S, length times width, but we can't find area because we don't have the side length. We don't have S, but we know the perimeter, which is the sum of all the sides. That's equal to 12. So what number added up 4 times is equal to 12? And the answer is 3. And again, there's no units because they didn't give us any units here. So now we can find the area because we know the side length is 3, so 3 times 3 is 9. So the area is 9. So if you got 9, good job. So now let's try 1D. Go ahead and try 1D, and when you come back, we'll do it together. All right, we're back. So I'll just redraw the square again just to keep the same structure. And we want to find the perimeter, which is the sum of all the sides. We can't find the perimeter because we don't know the sides. But we know the area is equal to the product of the length and width, and that's 81. So what number times itself is equal to 81? Well, the answer is obviously 9 if you know your multiplication facts. And we have to write the unit. The unit is inches because they did give us a unit. And this is not square inches. It's just your normal inch in one dimension. The area, 81, would be square inches, but we don't have to write the units when we're doing an equation. We just write the units at the very end. So we solve for S, and it's just one-dimensional unit, inches. So now we know S. We just plug in S for our perimeter formula, 9 plus 9 plus 9 plus 9. And 9 times 4 is same thing as 9 added up 4 times, and that's 36. And we do have to write our units, and perimeter is one-dimensional, so it's just inches, not square inches. So if you got 36 inches, good job. All right, so that was the first problem. Now we're going on to the second problem. The second problem deals with what are called composite figures. A composite figure is a figure that has more than one shape inside it. So you can see we have a rectangle, but we also have a triangle inside the rectangle. So this is a composite figure. So what we're going to do is we're going to find the area of the rectangle, which is everything inside, including the triangle. Then we're going to take that and we're going to subtract the area of the triangle, and that's going to give us what we're looking for, which is the shaded region, all this gray area, because they want us to find the area of the shaded region. So let's go ahead and do that. The area of the shaded region is equal to the area of the rectangle minus the area of the triangle. And in case you don't know, these are called subscripts. Whereas a power like this, for example, would be a superscript. All right, so now the area of the rectangle, to find the area of a rectangle, just multiply width times length. again, if you forgot how to do that, that's okay. I'm telling you right now how to do it, because you're definitely going to have to know that. And the area of the triangle, we have a formula for that we learned in the order of operations class. The area of a triangle is base, you know what, I'm just going to write the formula out here for all this. So length times width is the area of a rectangle. Area of a triangle is base times height divided by 2. So now we'll plug that in. Length is 3 and width is 6. Base of the triangle is 2, height is 1. And then we have to use order of operations. So I'm going to do multiple steps at once. Remember, you have to move left or right over here. 2 times 1 is 2. And then we have 18. 2 divided by 2 is 1. And finally, 18 minus 1. I'm going to go ahead and shrink this a little bit here. (18 minus 1 is 17. Now we do have to write. I got to shrink this even more. Sorry, or just move it up. (17), and we need, this is area, the shaded region. This is 2 dimensions, it's area. So we have to write not just inches, we have to write square inches with the 2 there. All right, so that's, again, that's finding the shaded area with composite figures. So let's try another one of those. Before you do one on your own, let's try 2b. What is the area of the shaded region below if the area of the circle is 1 square meter? So again, this is a composite figure. We have a rectangle here, and we have a rectangle here, and we have a triangle here, and of course we have that circle that I already shaded over. So this is a problem where it's going to look like we don't have some of the dimensions. Word problems are often designed to intimidate, like I said, to intimidate you, to make you think that there's not enough information to solve it, but there actually is. So let me copy this, because I don't want to mess up my original drawing. All right, obviously that's kind of messed up there, but so what we're going to do is we're going to find the area of this rectangle in here. Then we're going to find the area of this triangle. So this rectangle, this triangle. Then we're going to find the area of this rectangle, and we're going to add those all together. Then we're going to subtract the area of the circle, because we don't want that area. That area is not supposed to be filled in. It looks like it's filled in this drawing, but that's because I shrunk it. So the total area equals the area of rectangle 1 plus the area of the triangle plus the area of rectangle 2 minus the area of the circle. All right, so again, area of a rectangle is length times width. Area of triangle is base times height divided by 2. And area of the other rectangle is length times width again. And then minus the area of the circle, which we're just going to be told what that is. There's actually a formula that we learned to find the area of a circle. But just to make things a little faster, I'm not going to require you to use the approximation for that we learned in previously. So length times width. So here's where things get tricky. Here's where students really get stuck. So we have to find the dimensions of this rectangle here. That's the first rectangle we're going to find. So we need to find the width and the length. So this is actually fairly easy on this one, because the width is going to be 4 meters. Do you see why? Do you see why that's true? You make your rectangle here, and the width is 4 meters. It's very simple. And then the length is going to be 2 meters. That's this distance here. You need to see that. You need to understand that, or you're going to have no hope of doing these particular problems. So 2 times 4. Now we go to the triangle. Now here's where things get tricky. We have the base, you see. We have the base of the triangle, and by the way, you can see the triangle's upside down, but that's okay. We have the base of the triangle, but where's the height? There's no height, right? So we're stuck. So we give up, we quit, and we're done, right? Wrong. The height is there. It's just not labeled at this particular location. It turns out that the height is right here. That's the same length as the height. So we're told that's 2 meters. Do you see this 2 meters over here with the arrow that goes to that side? This is the height. So you don't give up and go play video games. You recognize that the height is there, and we know what it is. It's 2. So let's plug in the base is 4. The height is 2. And we're done with, we've got the triangle there. So now we move on to the rectangle over here. You see this rectangle? We have to find the length and the width of that rectangle. So this is the width. And now, again, we have a situation where we don't know this length. We have to find this length to find the area of the rectangle. It's not there. So again, instead of just giving up, you got to look at the information. We don't have this length directly labeled, but we do have this length, which is this part, the same length as that part, and then we have this length, which completes this side. So all you do is just add up those numbers. So we add up 2 plus 2, and that gives us the dimension, the length of that side. So that side is 4. Again, it appears that the answer is not there, but it is. Now we have to use the same logic when we're talking about width. Actually, no, we don't. Actually, the width on this one's just 2. I was thinking about something else. All right, minus the area of the circle. So we're told that the area of the circle is 1 square meter, so we just plug in 1 square meter there. And now we just have to follow PEMDAS. So 2 times 4 is 8. 4 times 2 is 8. And I know that I'm doing more than one step at once, but that's okay as long as you follow the general rules of PEMDAS. So now we have to do division first. 8 divided by 2 is 4. And again, you can show every step if you want to, but we don't have time for that. So 8 plus 4 is 12. And again, we have subtraction and addition, so we have to move left to right. And we get 20 minus 1. And finally, the area total is 19. And we have to put square meters. So there you go. All right. So that was a much harder one than the previous one we did. But hopefully you've got the main idea. So let's go. Why don't you go ahead and try problem 2C. And when you're done, we'll do it together. Pause the video. All right, we're back. We're going to find the area of this rectangle. See this rectangle here? And then we're going to add that to the area of this triangle. And then we're going to subtract the area of this square, and that'll give us our answer. So area total equals area of the rectangle plus the area of the triangle minus the area of the square. I'm just going to skip a line so we have more room there. So area of the big rectangle is fairly easy. That's just 8 times 12. So no tricks on that one. 8 times 12 is 96. You can do that on the side of the paper if you want, but I just did it in my head. So now, again, this is something where it seems like we don't have the information we need. We need the height, which is there, but we don't have the base. Where's the base? Where is it? Well, it's not labeled here, but it is labeled up here. You see, this length is the same as this length, which is the base of the triangle. Do you see that? You need to see that. All right, so now the area of the triangle is 8. The base times the height divided by 2. That's just how you find the area of a triangle. And then the area of the square is 3 times 3. So again, I'm going to skip a line here so we don't get all messed up. 8 times 2 is 16. 3 times 3 is 9. Again, you can sometimes do multiple operations. Just be careful that you don't do too much at once and confuse yourself. 96 plus 8 is 104. And 104 minus 9 is 95. And we need square feet. Again, these are area problems, so you always need your units to be square units. So if you got 95 square feet, that's very, very good. If you didn't get 95 square feet, that's fine. Just figure out what you did wrong and go back and fix it. All right, 2D, if the area of the circle below is 20 square feet, so that means the area of the whole circle inside is 20 square feet, and the side length of the square is 4 feet, so the side length here, it's a 4 feet all the way around, because squares always have, the sides of the squares are always the same length. What is the area of one of the sections inside the circle but outside the square? So go ahead and attempt this problem, and when you come back, we'll do it together. All right, we're back. So you probably noticed this problem is a little different than the ones we did previously, but again, word problems always have new things in them. There's no way you can avoid that. So what we're going to do, we're going to find the area of the circle, or area, the total area, the area that we're looking for. In fact, I don't know why I labeled those as total. I should have wrote area of the shaded region. I'm sorry about that. These should all be S for shaded region. I just realized that my triangle T is the same, so sorry about that. That's bad notation there, my fault. Area of the shaded region equals area of the circle minus the area of the square, and then we have to take all that and we have to divide it by 4, because this part here gives us the area of these potato wedge things here. It gives us all of them, but we don't want all of them. We just want one of them, so we have to divide by 4. All right, so the area of the shaded region, and again, we're looking for just one of these, is equal to area of the circle, which we're told is 20, minus the area of the square. Now, the area of the square is 4 times 4, because we're told that the side length of the square is 4. So area of the shaded region is, we have to use PEMDAS, do parentheses first. And inside the parentheses, we use PEMDAS again, so multiplication first. And then we have 20 minus 16 is 4. And then 4 divided by 4 is 1. So we have 1 square foot is the area of one of those potato wedge things. All right, so that was the second type of problem. Now we're on to the third type of problem. This is a problem where the intimidation factor is going to get to us. Again, word problems are sometimes designed to look really, really difficult. The people who write these problems, they want you to give up. If it takes 3 electricians to wire 36 microwaves in 4 hours, how many microwaves can 5 electricians wire in 7 hours? So again, this problem is designed to make you think that you cannot solve it. It's impossible for us to figure this out. But this is just a unit rate problem. They gave us a rate. They said 36 microwaves in 4 hours. That's a rate. But that's not a unit rate. In order for it to be a unit rate, you have to figure out how many microwaves in 1 hour. And we learned in the class on rates that to figure out the unit rate, well, let me write that rate first. So rate for 4 hours, let's put R equals 36 microwaves in 4 hours. So that's the rate, but we don't want that. We want the unit rate. The unit rate, in order to find the unit rate, we learned in the previous classes, the class on rate, that to find the unit rate, you just take this number and you divide it by this number. So 36 divided by 4, you know your multiplication fact, so that's 9 microwaves for every 1 hour. All right? So now that we have the unit rate, and that's for 3 electricians, the unit rate for 3 electricians. So we need to keep going, and we need to find the unit rate for 1 electrician. So to find the unit rate for one electrician, that's pretty easy to figure out. 3 electricians can wire 9 microwaves in 1 hour. Again, they told us how many in 4 hours, but we figured out for 1 hour. So nine microwaves in 1 hour, but that's for 3. 3 electricians can do 9 in 1. So we want to figure out how many microwaves one electrician. So obviously you just take 9 and divide it by 3. So that would be 3. One electrician can wire 3 microwaves in 1 hour. All right, so now that we have that information, the hard part is really over. The rest is going to be really easy. So if we know that one electrician can wire 3 microwaves in 1 hour, how many microwaves can 5 electricians wire in 7 hours? Well, now we're going to do the unit rate for 5 electricians. If each electrician wires 3 microwaves per hour, then 5 electricians obviously are going to do 15. So that would just be, in fact, let me go ahead and write this. So I'm just going to show what we did here. So that's U3 divided by 3, which is 3. And U5 is going to be U1 times 5, which is going to be 15 microwaves. So that's how many microwaves 5 electricians can wire. So we took this and multiplied it by 5. So now we know how many microwaves 5 electricians can wire every hour. But we want to know how many can the 5 electricians wire in 7 hours. So then the answer is just going to be U5 times 7. So 15 times 7. And you can do it off to the side if you want, but that's just going to be 105 microwaves. And I kind of lost room there, but you get the point. So again, that's a problem that seemed very, very difficult to do, but as you can see, the concepts were not that difficult to understand. And if you didn't understand the concepts, that's okay. We're going to do another one. All right, 3B. It takes 7 days for 6 tailors to make 168 t-shirts. How many t-shirts can 5 tailors make in 6 days? Or is it 3 days? So the rate for 6 tailors is 168 t-shirts for 7 days. We're going to find the unit rate for 6 tailors by dividing these two numbers. And those are kind of big numbers, so I'm going to go out to the margin here. We're going to have to use the long division algorithm. And we have 24, so 24 t-shirts every day. So 6 tailors can make 24 t-shirts in 1 day. So, and again, I didn't mention, you're probably wondering, well, why are we finding these unit rates? Well, the reason we find the unit rates is they're just easier to deal with. I should have mentioned that more clearly. When you're not dealing with unit rates, it's extremely difficult to do calculations. So we're changing to unit rates because it makes it so much easier. Now we know there's 24 t-shirts in 1 day. So now we figure out an even simpler unit rate. We figure out how many t-shirts one tailor can make in 1 day. So to do that, you just take U6, and there's 6 tailors, so you just divide by 6. And you get 4 t-shirts. 24 divided by 6 is 4. So 4 t-shirts per day. So now we know we're simplifying everything. We're making things easier and easier and easier. So now we know how many t-shirts one tailor can make per day. So now the rest is easy. How many t-shirts can 5 tailors make? So we have to find the unit rate for 5 tailors. So that would just be the unit rate for 1 tailor multiplied by 5. So we found U1 is 4 multiplied by 5, and we have 20 t-shirts per day. And so that's how many t-shirts that 5 tailors can make per day. So now we have 3 days. So the answer is just going to be equal to U5 times 3, 20 t-shirts per day, and there's 3 days. So obviously you just multiply and we get 60 t-shirts, and like the previous problem, I'm running out of room here. Sorry about that. 60 t-shirts. Again, this problem is designed to intimidate you. It's designed to make you think you can't do it. But now we know how to do it, so there's no excuse. Even if you don't understand the concepts, just figure out how to do it. All right, so it's time for you to try. Go ahead and attempt number 3C, and when you come back, we'll do it together. All right, we're back. So the rate for 4 assemblers is 32 computers for every 2 days. So you divide those two numbers, and that gives you the unit rate for 4. 32 divided by 2 is 16. That's not one of our multiplication facts, but you can figure that out. Now we want to find the unit rate for 1. We want to find the unit rate for 1 tailor. So that would be 16 divided by, it would be U4, which is 16, and divide that by 4. 16 divided by 4 is 4. So now we know how many computers 1 assembler can build per day. That's 4 computers. So we reduced everything to simpler numbers. Again, the unit rates are easier to work with. So now we want to know what is the unit rate for 5 assemblers. So that equals the unit rate for 1 assembler times 5. So the unit rate for 1 assembler we found is 4, multiplied by 5, and we get 20 computers per hour. Excuse me, that should be per day. 20 computers per day, but now we have 10 days. So the answer is going to be U5 times 10. U5 is 20. And you know from the previous classes that when you just multiply a number by 10, you just add 1 0. So you add a 0 to 20 and it becomes 200 computers. So if you got 200 computers, good job. All right, it takes go ahead and try 3D, and when you come back, we'll do it together. Pause the video. All right, we're back. It takes 2 workers to build 10 machines in 5 days. How many machines can 8 workers build in 3 days? All right, so the rate for 2 workers is 10 machines in 5 days. You just divide those two numbers to get the unit rate for 2 workers. 10 divided by 5 is 2. And then to find the unit rate for 1 worker, it's just the unit rate for 2 workers divided by 2. I guess I can write that down here. I probably should just do what I did before. So 2 divided by 2 is 1 machine per day. All right, so 1 worker can build 1 machine per day. How many machines can 8 workers build? So we want 8 workers. So we want the unit rate for 8 workers, which equals the unit rate for 1 worker times 8. Unit rate for 1 worker is 1, so times 8 would be 8 machines per day. That's how many machines per day that 8 workers can make. So now there are 3 days. So the answer is going to be U8 times 3 days. The unit rate for the number of machines that 8 workers can make per day times 3, because there's 3 days. So that would be 8 times 3 is 24 machines. So if you got 24 machines, good job. And you know, if you didn't get 24 machines, that's fine. Just go back and figure out what you did wrong. Again, these problems are designed to be intimidating. There's a lot of steps. There was 1, 2, 3, I believe there's 4 steps in that problem. So quite a few steps. All right, so now we've done the first 3 problems. Let's go on to number 4. This is another problem that's designed to intimidate you, but you're going to find it's really not that difficult. An object travels on the sides of the shape below. So it travels on the sides. It takes the object 3 seconds to move from one corner to the next. So 3, 3, 3, 3, 3, like that. If the object starts on the bottom right corner and moves clockwise, meaning this way, this rotation, at which side will it be after traveling for 2,048 seconds? So think about that. Think about what it's asking you. We're starting here. We're moving from corner to corner to corner, and it takes 3 seconds for each of these sides. And they're asking you what side is the object going to be at after 2,048 seconds. So this problem seems impossible to solve. I mean, how can we do this? Well, again, there's kind of a trick. Again, word problems are designed to be tricky sometimes. So what we do is we figure out how many seconds it takes to start from here and go all the way around and come right back to where you were. So there are 1, 2, 3, 4, 5, there are 6 sides to the shape. So each side is 3 seconds, so you just do 6 times 3. So time for one cycle is 6 times 3. Maybe I should label that. Equals 18 seconds. So that's the time for one cycle. Now what we're going to do is we're going to figure out how many cycles are there in 2,048 seconds. And then we're going, after we figure out how many cycles are in 2,048 seconds, we're going to figure out how many seconds are left over. So we're going to go around and around and around and around. And then when we figure out how many cycles there are, we're going to figure out how many seconds are left over, and that's going to tell us, so once all those cycles are done, we're going to end up right back where we started, and then the leftover is going to tell us how far we're going to go from that point. So for example, if we have a leftover that goes to here, leftover seconds that takes us there, then this side will be the answer. That's where the object will land. So this problem, again, it seems difficult, but we have to figure out how many times 18 goes into 2048. So that's a division problem. And really what we're asking is what is the remainder? That's what we're looking for. This is a remainder problem. 18 doesn't go into 20, or it doesn't go into 2, but it does go into 20 one time. I'm just going to do this quickly. Whoops, it should be 8. 18 goes into 68, I think 3 times, 24. And we're left with 14. So that 14 is the important part of this problem. Well, all parts are important in this case, but 14 is what we're looking for. So what this means, let me stop right here and explain to you very clearly what this means. And by the way, does this seem intimidating? Does this problem seem intimidating to you? Well, it should seem intimidating. It's supposed to be intimidating. The person who wrote this problem is trying to intimidate you. So don't get discouraged if this problem is intimidating. It's supposed to be intimidating. So don't worry about it. And remember, there's only 10 problems that I'm requiring you to do. So what this means is you go around this shape 113 times. So after 113 times, you end up right back where you started. From that point, you then move 14 seconds clockwise. Again, it's clockwise. So 14 seconds, because that's the leftover. That's the remainder. There's 14 seconds left after 18 goes in 113 times. So if you were to multiply 18 times 113, whatever that number would be, there would be a leftover 14 if you subtract that from 2048. I don't mean to get wordy on you, but that's what that means. So now we start here and we go 3 seconds and then another 3 seconds, add those up, that would be 6 seconds. Then we go another 3 seconds, that would be 9 seconds. And remember, we're trying to get to 14 seconds. Then we go another 3 seconds, and we have 12 seconds. Then we go another 3 seconds, and we have 15 seconds. So you see what happened there? We went from here, which was 12 seconds, to here, which is 15 seconds, starting from here. So that means 14 seconds has to be on this side, between 12 and 15. So the answer to the question is, maybe I should put a little thing here. That was kind of messy, sorry. So that's where we end somewhere on that side. So the answer to the question is upper right side. That's the answer. All right. So I know that's a lot to think about, but we're going to do one more of those. This is the same problem, but you're starting on the top here, and you're going counterclockwise. So you're going in this rotation. And we're doing let's see, 2 minutes to move from one corner to the next. So I know that all that stuff up there seemed really difficult, but I'm going to do it the fast way now, because I'm not going to explain everything here. I'm just going to do it the fast way. I don't want you to get the idea that these problems take a long time. They don't. If you know how to do them, you can do them really quickly. You can get them done in about 20, 30 seconds. So we need to figure out the time for one rotation. And instead of saying rotation, I should really say cycle. Time for one cycle is, there's 1, 2, 3, 4, 5 sides. So 5 sides times the amount of time it takes to go from corner to corner. And that equals 5 times 2 is 10 minutes. So it takes 10 minutes to do one full cycle. So we want to figure out how many times 10 goes into 195 minutes, because this problem is 195. 10 goes into 19 one time. 10 goes into 95 9 times. And the remainder is 5. So that means we go around counterclockwise. We go around 19 times, and then we end up, after 19 times, we end up right back to where we were at the start. And then you go 5 more seconds. So 1, 2, 3, 4, 5. So that's the side that we end on. So that's the answer is bottom side. All right. So now it's time for you to attempt some of these problems. So go ahead and try number 4C, and when you come back, we'll do it together. All right, we're back. So we need to find the first thing to do is find the time for one cycle, which is 5 seconds, and there's 1, 2, 3, 4, 5 sides. So 5 sides, just like the previous problem, there were 5 sides, times 5 seconds, which is a total of 25 seconds for one cycle. All right, so we want to see how many times 25 goes into 211. And that doesn't go into 2, doesn't go into 21, but it does go into 211. Goes, I'm going to say 8 times. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. Sorry, I gave you kind of a hard one there. Bring down 11. So 11 is the remainder. So we go all the way around 8 times. We start here and we go clockwise. So that would be 1, 2, 3, 4. We go all the way around 8 times, and then we end right where we started. And then the remainder is 11. So we go 5 seconds for each side. So 5, 10, 11. So that's the side that we end at. So right over here somewhere. So we have to, it's the bottom right side. So if you got the bottom right side, good job. All right, so I'm really proud of you if you did that problem correctly. If you didn't get the right answer, that's okay. Just go back and figure out what you did wrong. So I'm going to leave that one open there so you can see it. So now try 4D, and when you come back, we'll do it together. All right, we're back. So first step is figure out time for one cycle, which is 9 seconds, and it's 3 sides. So 3 sides times 9 seconds equals 27 seconds. Then we have to see how many times 27 goes into 734. Looks like I'm giving you some difficult numbers here to deal with. I'm sorry about that. I did the easy ones. You have to do the hard ones. So we're going 2 times 7 is 14. Carry the 1. 2 times 2 is 4, plus 1 is 5. I taught you these fast methods to do this. If you don't remember them, you can just go back to the long division class and look at the fast ways to do these. So I'm going to do 73. I'm going to borrow from 7, give to the 3, becomes 13, subtract. You get 9. 13 minus 4 is 9. All right, so then we bring down the 4. 127 goes into 194. I'm going to say 7 times. 7 times 7 is 49. 7 times 2 is 14. That's 18. And we're going to subtract, so you can just do that in your head. You really don't have to borrow and all that type of stuff. So our remainder is 5. So that means you go around counterclockwise 27 times, because we have a 27 here. And then after 27 times, you get right back to where you were. And then we go 5 seconds. So from here, you go 5 seconds, and it's 9 seconds on each side. So 5 seconds would just take you to about the middle. So the answer to this one is on the right side. Looks like most of these problems, the answer is always on the right side. That was just a coincidence. So if you got the right side, good job. I'm proud of you. These are some challenging problems. All right, so now we're on to number 5. If Bill threads 3 square inches of clothing material every hour, and Lana threads 4 square inches every hour, how many square inches of clothing material will they thread in 12 hours if they work together? So this guy he threads 3 square inches, and Lana threads 4 square inches. So if they both work at the same time, they're going to thread 7 square inches. So the unit rate for Bill is 3 square inches per hour, and the unit rate for Lana is 4 square inches per hour. So the unit rate for both Bill and Lana is 3 plus 4, which is 7 square inches per hour. So this problem, again, it seems intimidating, but it's really not. If both these people start at the same time, and that's one of the assumptions of these problems. Normally when you're given this type of problem, they don't tell you that they're starting at the same time. If they're not starting at the same time, it's not exactly obvious that you add the numbers up. But we're assuming that they're starting their work at the same time, which means that they're both going to, in 1 hour, they're going to thread 7 square inches per hour. You just add the rates together. That's the purpose of this problem, is to teach you just add the rates together. So now we know that they thread 7 square inches per hour. We want to know how many square inches they can thread in 12 hours. So that's just 7 for 1 hour, 14 for 2 hours, 21 for 3 hours, so on and so forth. Obviously, you can tell it's just going to be multiplication. You just take this number and multiply it by 12. All right, so the answer is equal to the unit rate for Bill and Lana times 12, which is equal to 7 times 12, and you can do that off to the side if you want, but it's just going to be, I'm going to bring this down here because I'm running out of room. Remember, you can go to the right or you can go down, but you got to line up those equal signs every time. 7 times 12, that would be 84 square inches. All right. So I know what you're thinking. You're thinking, I want to have more practice with these problems. Well, we don't have time to do a huge amount of practice for all these problems. because we wouldn't be able to get to very many problems if we had like 20 problems for each version of these. So with word problems, you're kind of you have to kind of move on to the next one. All right, 5C. A charity raises $2,400 per month. A second charity raises $4,000 per month. If the charities combine their funds, how much money will they raise in 8 months? So the unit rate for the first charity is $2,400. The unit rate for the second charity is $4,000. If they both work together, you just add the rates up. So the unit rate for charity 1 and charity 2 is just 2,400 plus 4,000, which is 6,400. You can do that in your head. If you want to set it up, you can do it, but that's really easy to do in your head. I should say, I'm sorry, I should be writing my units here. Move that over. We need a dollar sign, always goes in front. Why does it go in front? I don't know. It's just the way our language works. And let me move that over. Per month. So this is the new rate that both charities raise per month. But now we want how much will they raise in 8 months? So let's see here. The answer is going to be the rate for both charities times 8 months. So 6,400 times 8. And that's kind of a big number, so maybe we should do that over here. 6,400 times 8. 8 times 0 is 0. 8 times 0. 8 times 4 is 32. Carry the 3. 8 times 6 is 48. It's 51. So $51,200. That's quite a bit of money there. All right. So that's another example. Now, I just realized that, let's see here. These letters are all messed up. That should be B. That should be C. So I just realized that the next problem is kind of different than the problems we just did, so it's kind of unfair to ask you to do a problem that has a slight difference to it. I'm going to go ahead and ask you to try problem C, but I'm just going to warn you, problem C is not using multiplication at the end. It's actually using division. So go ahead and try 5C. If you get stuck, we'll do it together, and we're going to do it together anyway. So pause the video and try 5C. All right, we're back. Katie and Donnie are drinking from the same soda glass with 2 straws. If Katie drinks 1 ounce of soda per minute and Donnie drinks 3 ounces of soda per minute, how long will it take them to drink 10 ounces of soda? So it's asking how long. That's the difference between this problem and the other problems. So you're going to have to use division. All right, so Katie, the rate for Katie is 1 ounce of soda per minute. And the rate for Donnie is 3 ounces per minute. I'm sorry, that should be unit rate. Those are all unit rates because the second number is 1 minute. It's per minute, so they're all unit rates. The unit rate for Katie and Donnie is 1 plus 3, 4 ounces per minute. So, let's see. So now, that's how fast that they're drinking together. So how long will it take them to drink 10 ounces of soda? So this is a little bit different. They drink now listen very carefully. This is 4 ounces for every 1 minute. They drink 4 ounces of soda for every 1 minute. Okay, now they're not drinking 4 ounces of soda. They're drinking 10 ounces of soda. So how many minutes is it going to be? You want to figure out how many times 4 goes into 10. You can kind of get an idea of just thinking about it. So the answer is going to be, how many times does 4 go into 10, which is 10 divided by 4. 10 divided by the unit rate for Katie and Donnie. 10 divided by 4. And 4 goes into 10 how many times? So we can do the long division algorithm if you want. And we have to bring down a 0. We're going to put a decimal. So this is actually a decimal problem. So we have 2.5. 2.5 and the units are minutes. So that's the answer. It takes them 2.5 minutes, 2.5 minutes. 5/10 is the same thing as 1/2. Now I want you to be aware that you could also write 2 and 1/2. Remember, we can go back and forth between mixed numbers and fractions and decimals and all that type of stuff, percents. But you shouldn't write this problem as a percent. All right, so sometimes in these problems you'll be asked to multiply, sometimes you'll be asked to divide. All right, so why don't you try 5D, and when you come back, we'll do it together. All right, we're back. A toy company has a machine that makes stuffed bears. It makes 25 bears each hour. If the company buys an additional machine that makes 30 bears per hour, how long will it take the company to make 400 bears? So the unit rate for the first machine, I'll say M1 for machine 1, is 25 bears per hour. Unit rate for machine 2 is 30 bears per hour. So we want the unit rate for machine 1 and machine 2 working together, and that would just be 25 plus 30 is 55 bears per hour. So if you turn on both machines at the same time, they're going to make 55 bears per hour. All right, so this is another division problem. So again, I kind of tricked you by doing multiplication problems, and then I switched to division. I didn't mean to do that, but 55 bears in 1 hour. Okay, that's how long it takes. It takes 1 hour to make 55 bears, but we don't care how long it takes to make 55 bears. We want to know how long it takes to make 400 bears. So again, it's just a division problem. How many times does 400 go into, or excuse me, how many times does 55 go into 400? So the answer is equal to the unit rate for machine 1 and machine 2 working together divided by, or excuse me, that's the wrong order there. 400 divided by the unit rate for machine 1 and machine 2 working together. So that's 400 divided by the unit rate for machine 1 and machine 2 working together is 55. So then we have to do, that's quite a big number, so we're going to have to use a long division algorithm. 55 doesn't go into 4, doesn't go into 40, but it does go into 400. So we're just going to have to guess here. If you round it off to 50, 50, 100, 150, 200, 250, 300, 350, 400, so that's 8 times. But since there's a 5 there, so I'm going to round it down to, I'm going to say 7 times. 7 times 5, 35, carry 3, 7 times 5, 35, plus 3 is 38. And you can borrow from the 4 and do all that type of stuff and make this 10, then borrow. And you can review all that, but it's just going to be 15. 400 minus 385 is really easy. You should probably do that in your head. All right, so now we have 7. It's going to take 7 hours. But now here's something new. Here's something that you can keep going and change this to a decimal if you want. If you keep going, that would be, let me get my calculator here. That would be 400 divided by 55 is, that would actually be a repeating decimal. You can write it as a repeating decimal, but I'm going to use what we learned in the class 33, I think it was, where we're going to take the remainder and we're going to write it there, and we're going to take the divisor and we're going to write it here. So that's when you change the when you want to write the quotient as a mixed number instead of a decimal. So you take the remainder and write it in the numerator of the fraction, and you take the divisor and write it in the denominator. We went over that in the in class, I believe it was 33. So now we can reduce this fraction, never leave a fraction in the non-reduced form. We can divide both these numbers by 5. 15 divided by 5 is 3, and 55 divided by 5 is 11. So our final answer is 7 3/11 hours. And you can just write H for hours, or you can spell out the name. All right, so that's the fifth problem. Now we go on to the sixth problem. Now I think the sixth problem is probably going to be the most intimidating problem of all these. This is a problem that most, or I don't know if I could say most, but a lot of high school students, even the best students, they look at this and they have trouble with this. But again, even if you don't understand the concept of the problem we're about to do here, you can still learn how to do it. The algorithm for doing it is very easy. Once you learn how to do it, then you can go back and think about why it works. So below is an image of a water tank. If drain A is opened, so drain A is here, if that drain is opened, the tank will drain completely in 5 minutes. If drain B is opened, instead of drain A, the water will drain in 6 minutes. If both drains are opened instead of the first two scenarios, in other words, if both drains are open at the same time, how long will it take for all the water to be drained? So you may be able to solve this problem. If you like these types of problems, if you think about this type of stuff a lot, you might be able to solve it on your own without me even telling you how to do it. I mean, it's not something that you couldn't figure out on your own if you really wanted to. But most students look at this and they're not quite sure what algorithm to follow to figure out this problem. So what we're going to do is we're going to find the rate for drain A. One tank is drained every 5 minutes, and the rate for drain B is one tank is drained every 6 minutes. So these are rates. We have tank per minute. Those are the units. These are both rates. But these are not the unit rates. Again, for them to be unit rates, this number has to be 1. We have to figure out how much of the tank is drained every 1 minute. This, there's a 1 here, but in order for it to be a unit rate, we have to have a 1 in the second number. Because if we can figure out how much of the tank is drained every 1 minute, then we can start to figure out what's really going on here. So to find the unit rate, as you recall, we just take the first number and divide by the second number. So if you do that, 1 divided by 5, 5 doesn't go into 1, so add a 0. Goes in 2 times, remainder 0, bring the decimal straight up, so we have 0.2. So that rate is equal to 0.2. And you can use that decimal, 0.2. There's 0.2 tank per minute, every 1 minute. But that's kind of difficult to understand that as a decimal. It doesn't really make a lot of sense to say it as a decimal. And in this case, we have an even more difficult situation with the other rate, because if we divide with that one, we end up with 0.116 bar. So it's difficult to change these to decimals to find the unit rate. So instead of doing that, we're going to do it a slightly different way. It turns out when you take 1 and divide by 5, your answer can also be written as simply 1 over 5. 1/5 of a tank is drained every 1 minute. So 0.2 is the same thing as 1 over 5. So we went over that a little bit in the rates portion of this course, but this is something that we didn't quite go over a lot, and I want to go over it more now. We want to divide 1 by 5. If you divide 1 into 5 parts, how big is each part? Each part is simply 1/5. I mean, think about that. If you divide one pizza into 5 parts, How big is each part? Well, it's 1/5. It's very simple. It seems really difficult, but it's really a simple concept. If you divide if something that's whole into 5 parts, each part is going to be 1/5, right? So that's the unit rate. That's probably the most difficult thing to understand about this this problem. It's not that it's really difficult, I guess, to understand. It's just we're using concepts that we haven't learned easy algorithms for. So 1/6, that would be 1/6 of the tank is drained. 1/6 of the tank, or a tank, however you want to say it. Probably should say the tank, but who cares? For every 1 minute. So I'm going to shrink that stuff because we're running out of room here. So that will be the unit rate for A and the unit rate for B. So now that we have the unit rates, this drain, so let's go back to the problems we did previously. I did the previous problems on purpose to prepare you for this problem. This drain drains 1/5 of a tank every minute, and this drain drains 1/6 of the tank every 1 minute. So to figure out how fast the tank is going to be drained when both drains are opened, that would just be, so the unit rate for both A and B is just going to be the sum of the two rates, just like the previous problems that we did. So 1/5 plus 1/6. So, we're trying to add fractions, but we can't add them because they don't have the same denominator. They're counting the same different size pieces. So you have to multiply both sides of this fraction by 6 to get 6/30, and multiply both sides of this fraction by 5 to get 5/30. Now we can add those up. 6/30 plus 5/30 is 11/30. So now we have the rate in terms of the fraction of the tank. So 11/30 of a tank is drained every 1 minute. And you can just say MIN, or you can put the 1 right there, it doesn't matter. Alright, so 11/30 of a tank is drained every 1 minute. So now we're starting to get somewhere. Now you can actually look at that, and you can actually estimate approximately how long it would take to drain the tank. 11/30 is 1 minute, so you can double that to go to 22/30, and that would be 2 minutes. And you're getting really, really close, because we want to drain the whole tank. The whole tank, if you divide it into 30 parts, would be 30 out of 30. That would be one whole tank. This is 11 out of 30 is 1 minute. Times it by 2, you get 22 out of 30. It would be 2 minutes. So you can see, and of course, if you multiply by 3, you get 33 out of 30. That would be more than one tank. So it's got to be somewhere between 2 minutes and 3 minutes. So what we do is, and this is another step that is pretty difficult for people to conceptualize, but we're just trying to figure out how many times, figure out how many times this number goes into 30/30. 30/30 is a full tank. Trying to figure out how many times it goes into, how many times 11/30 goes into 30/30. Because how many of these 1 minutes will fit into 30/30, a full tank? So again, I just want to make sure you understand this. 11/30 of the tank are drained every minute. Okay, the tank is going to be completely gone when 30/30 of it is drained, obviously. 30/30 is all the whole tank. So you want to figure out how many times this number goes into 30/30. Because how many minutes is it going to take? So 11/30 for 1 minute, you want to get to 30/30. So how many times do 11/30 go into 30/30? So that's division. All right, but here's another important point. 30/30 is just one whole. So all you're doing is just adding, or you're dividing 1 by 11/30. All right, now again, I'm going to show you the fast way to do this. You don't need to think about every single one of these steps, so don't get discouraged by this. When you learn the fast way to do it, this problem is going to take you about 30 seconds. So anyway, let's go to the division algorithm for fractions. This is review stuff. So remember, when you divide fractions, you switch the operation, and you flip the divisor. So that would be 30 over 11. And this becomes 1 over 1. 1 is just the same thing as 1 over 1. And now we're just multiplying fractions. This is all review stuff. 1 times 30 is 30. 1 times 11 is 11. So now that's our answer. But unfortunately, we're still not done. I know what you're thinking. I want to be done by this point. Well, we have one more thing to do, because do you see a problem with this? That's an improper fraction. We're not allowed to leave improper fractions. So we have to convert to a proper fraction. So the way to do that is we learned figure out how many times the denominator goes into the numerator. It goes in 2 times. 2 times 11 is 22, and what's the remainder? 30 minus 22 is 8. That goes in the numerator, and the divisor stays in the denominator. So we learned how to do that in previous classes. That's how you convert an improper fraction to a mixed number. If you want to go and review that stuff, you can go back to those classes and review that stuff, but we don't have time to do that now. So 2 and 8/11 minutes. That's how long it takes those 2 drains to completely empty the tank. So all that said, I'm now going to go a little faster here, because I don't want you to think that that problem needs to take a long time necessarily. The concepts are fairly advanced, but anyway, let's see. There's a dry lake bed. There are 2 dammed up rivers that can fill the lake. So dams just block the rivers. One of the rivers can fill the lake in 5 days if the dam is open. The other river can fill the lake in 10 days if its dam is open. If both dams are opened, how long will it take to fill the lake? So this is the same type of problem. But instead of draining something, you're filling something. It's the same situation. So the rate for river 1 is it can fill 1 lake in 5 days. That's not a unit rate. Instead of writing, well, I guess I'll just write it over here. River 2 it can fill 1 lake in 10 days. So those are not unit rates. The unit rates are going to be 1/5 of the lake, I should say, in 1 day. And again, that's just basic logic. If it takes 5 days to fill 1 lake, then obviously in 1 day it's going to fill 1/5 of the lake. You don't even need to think about an algorithm. You can kind of just see that. And I should write unit rate, not R. That's the unit rate. And the unit rate for the second river is 1/10 of the lake every 1 day. Again, that's just kind of common sense there. So we want to find the unit rate, how fast it's going to fill up the lake if we open both dams and let both rivers flow. That's just going to be 1/5 plus 1/10. So we cannot add those fractions because they don't have a common denominator. So we're going to multiply both sides of this fraction by 2 using the fundamental principle of fractions. And now we can add those up, and we have 3/10 of the lake is filled per day. So we want the lake to be filled. The lake is 10/10. We want 10/10 to be filled. So we know 3/10 of the lake is filled every 1 day. So we want to figure out how many times 3/10 goes into 10/10. But again, we don't want to write 10/10. We just want to write 1, because the algorithm is much easier. So same thing, we flip operation, multiply straight across, you get 10 over 3. We just have to convert that to a mixed number. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. That goes in your numerator. Your denominator stays the same. And we have 3 1/3 days. So again, I know that problem is very, very challenging. I chose it for that exact reason. I want you to start to get confident doing some more difficult problems. High school students would have trouble with those problems. In fact, a lot of high school students would just give up. In fact, to be honest with you, I think most high school students would give up on that problem. But all you have to do is remember how to do it. You don't necessarily have to remember every single concept. The purpose of these problems is to start to get the juices flowing. Okay, it's to start your thinking, to start to increase your confidence. You don't have to understand everything in this first class that we're learning these multi-step word problems. But you do have to know how to do all 10 of these problems, whether you understand them or not, because that's the start. That's the beginning of your understanding. All right, 6C. So now it's your turn. I'm going to see if I can zoom out here so you can see what we did. You can see 6A there. So use 6A to do 6C, and when you come back, we'll do it together. All right, we're back. So I'm going to do this problem quickly. So the unit rate for the the drain plug and the hose is going to be 1/9 plus 1/6. Multiply, you get a common denominator, you get 2/18 plus 3/18 is 5/18, and that's the unit rate if you take the hose off and the drain plug. So that would be I'm just going to say of a tank. There's some tank somewhere every second. So 5/18 of the tank is drained every second. So then, as usual, you just take 18/18 and divide by 5/18, which is the same thing as 1 divided by 5/18. You flip the divisor, multiply straight across, you get 18 over 5. 5 goes into 18 3 times. 5 times 3 is 15. 18 minus 15 is 3. And the denominator is always the same. So that's 3 3/5 seconds. So if you got that answer, good job. Now, again, these are challenging problems. If you were to give this problem to your parents, most parents would have trouble solving this problem. So, again, the purpose of these problems is to increase your confidence. Let's do 6D. And go ahead and attempt that problem on your own. And when you come back, we'll do it together. All right, we're back. The unit rate for hose 1 is 1/7 of the pool per hour. And the unit rate for hose 2 is 1/8 of the pool. I'm just going to say pool. I want to write that out. So we want to figure out the unit rate for both hose 1 and 2. That would just be the sum. And I don't think that we can reduce that. So 15/56 of the pool is filled every hour. And we need to figure out how many times that goes into 56/56, because we're trying to fill the entire pool. And of course, that's 56 over 56 is just 1. And as usual, I'm going to put a divider here. As usual, we just change the multiplication, flip, and we end up with 56 over 15. And 15 goes in, I believe, 3 times. 15 times 3 is 45. You can do that off to the side if you want. And 56 minus 45 is 11. And the remainder always stays the same. And we have hours. That's how long it takes. So if you got 3 and 11/15 hours, good job. So again, if you don't understand the concepts, just learn how to do the problem. You write these numbers under 1, the time it takes to fill the pool for each. You add the fractions together, and then you just flip this basically. That's always how it works, and then you change it to a mixed number. So you can do all of that. Even if you don't understand every concept, you can do that. Just learn it, and then you can go back and try to figure out the concepts later. The most important thing is you're actually able to do the problem. All right, so now on to problem 7. a business is owned by 5 people, each with an equal share, and you are one of those people. If a shareholder sells you 1/2 of his share and another shareholder keeps 2/3 of his share and sells you the rest, what fraction of the business will you own? So these problems are all just about finding fractions of fractions. So you own 1/5 of the business to start off. All right, now the second shareholder, he wants to give you 1/5 of, he wants to give you 1/2 of his 1/5. So you have to find what fraction of the entire business he's giving you. So they tell us he's giving 1/2 of his share of the business. He's not giving you 1/2 of the business. He doesn't own 1/2 of the business. He owns 1/5 of the business. But this is saying he's giving you 1/2 of 1/5 of the business. So this is, again, this is just finding a fraction of a fraction. To find a fraction of a fraction, you just multiply. We learned that in a previous class. So second person gives you 1/2 of 1/5. So if you want to find a fraction of a fraction, you just multiply those. Again, we learned that in a previous class. So 1/2 times 1/5 is 1/10. That's what all these problems are going to be, just finding a fraction of a fraction. So now this other guy, we have to be careful here because this is kind of a tricky part. This other guy keeps 2/3 and sells you the rest. So he's not selling you 2/3 of his share. If he keeps 2/3, then that means 1/3 he's giving away. So he's giving, let's see, third person gives you, so you have to take 3/3 and subtract 2/3, which gives you 1/3. He's giving you 1/3 of 1/5. So using PEMDAS, 3/3 minus 2/3 is 1/3. I'm just showing every step here. So 1/3 of 1/5 is multiplying. 1/3 times 1/5 would be 1/15. So he's giving, so you own, so let's go back. The hard part is over pretty much. You own 1/5. This guy's selling, or he's not giving you, he's selling you 1/10. And this other guy is selling you 1/15. So now all you have to do is just add all those fractions. And you're done. So let's do that. The answer equals 1/5 plus 1/10 plus 1/15. So now we have to find a common denominator. It looks like the common denominator is going to be 30. So we're going to multiply both sides of the first fraction by 6 to get 6/30. Both sides of the second fraction by 3 to get 3/30. Both sides of the third fraction by 2 to get 2/30. Add all those up. I'm going to make a divider here. Add all those up and you get 11/30. So that's the fraction of the business that you now own. All right, let's try another one of those. Leslie wants to fill her fish tank with water. Actually, I think that's the wrong problem, sorry. A pizza is divided into 8 slices. Each person in a group of 4 takes 2 pieces. If you are one of these people and one of the other individuals gives you 1/6 of his share of the pizza and another person gives you 1/3 of one of his slices, what fraction of the entire pizza will you have? So these problems can be tricky. They can be very tricky. So you got to be careful here. Again, we're just finding fractions of fractions, but be careful. So your share is 2 out of 8 because each person gets 2 pieces. So you can go ahead and reduce that to 1/4, divide both sides by 2. And the second person is giving you 1/6 of his share. So each person gets 2/8. but 2/8 reduces to 1/4. So each person is gets 1/4. So this person gives you 1/6 of 1/4, which is 1/24 of the total pizza. Again, these fractions that we're dealing with, we're trying to figure out what fraction of the entire pizza. That's what all these problems are all about. What fraction of the entire business? What fraction of the entire pizza? Those are the fractions we're interested in. So now, the third person, now this is where you got to be careful. Don't make a mistake here. The third person gives you 1/3 of one of his slices, not 1/3 of his share. His share is 1/4. Okay? He's giving you 1/3 of a slice. So 1/3 of a slice is 1/3 of 1/8, not 1/3 of 1/4, because a slice is 1/8. A share is 2/8, because each person gets 2 pieces. So multiply those and you get 1/24 again. All right, so it was just a coincidence that they ended up being the same, because here you're trying to find 1/6, here you're trying to find 1/3. All right, so now we just add those up, and that's our answer. So these problems aren't so bad. The hard part is just understanding that finding a fraction of a fraction is just multiplying fractions. Now, I know that you probably don't quite understand that fully, but join the club of millions of students. Most students don't fully understand why finding a fraction of a fraction is interpreted as multiplication. They don't understand it, but they will still take the test and get an A on the test. Why are they going to get an A? Because they just remember to find a fraction of a fraction, you multiply. If you want to explain why that algorithm works, then you just have to use geometry. But again, most students don't want to do that. They just want to learn how to do the problem and go on with the rest of their life. So now we're going to add those up. All right, and multiply both sides of this fraction by 6, and you get 6/24. I'm waiting for that to go away. 6/24, and now we have a common denominator. So we just add those together, and we get 8/24 of the pizza, which reduces, divide both sides by 8, and you get 1/3 of the pizza. So you got 1/3 of the pizza because all those people were generous and they gave you parts of the pizza that they didn't want. All right, so again, you're just finding fractions of fractions. So I know these are challenging, but that's why I'm giving them to you. There's only 10 problems in this class. Calm down. Don't worry if you don't understand everything. Try 7C, and when you come back, we'll do it together. All right, we're back. So you have 1/10, and this person finishes only 1/4 of his work. So if he only finishes 1/4 of his work, that means there's 3/4 of 1/10 that he didn't do, and the other person, let's see, another person leaves for another job after finishing only 4/5. So that means he didn't finish 1/5 of his work. So you have to finish 1/10 of the mural, which was your portion of the work, but you also have to finish these parts that the other people didn't do. So all you have to do is just calculate these. So that would be 3/40, and this would be 1/50. And so now you just add all those up. The answer is equal to 1/10 plus 3/40 plus 1/50. And now we just need a common denominator, which I think is going to be 200. So, sorry I'm giving you big numbers there. Multiply both sides of that fraction by 20, and you get 20/200. And multiply both sides of this fraction by 5, and you get 200. Multiply both sides of this fraction by 4, and you get 200. All right, so now we add those up, and you get 39/200. So you have to complete 39/200ths of the mural. All right. So if you got 39/200ths of the mural, that's really, really good. Good job. If you didn't, that's okay. Just figure out what you did wrong. Now, try 7D. 7D is going to be quite different because we're not just going to be adding fractions. We're also going to be subtracting fractions. But it's the same principle. This is going to be a little bit more challenging, so why don't you go ahead and try that. If you can't do it, that's okay. We'll do it together. All right, we're back. So a bottle contains two chemicals, chemical A and chemical B. 1/4 of the bottle contains chemical A. Chemical A is 1/4, which means that chemical B is 3/4 of the bottle. After sitting on a shelf for 3 years, 1/3 of chemical B, and by the way, this is information that we really don't care about. We don't care about that 3 years. That doesn't make any difference to us. 1/3 of chemical B converts to chemical C. So 1/3 of this converts to chemical C. And 1/2 of chemical A converts to chemical B. What fraction of the entire bottle is chemical B? I should say, what fraction is now chemical B? Is now chemical B. All right, so you already have chemical B, but the problem is you're losing chemical B. So you start off with, it tells us 1/4 of the bottle is chemical A, so that means 3/4 is chemical B, as we said over here. So 3/4 is chemical B, but you're losing. Let's put B with a colon because we're talking about B here. But you're going to lose 1/3 of chemical B. So 1/3 of 3/4 you're going to lose. But you're also going to add chemical B because chemical A converts to chemical B. So you're going to add 1/2 of 1/4 because 1/4 is chemical A, but it's going to 1/2 of it's going to convert. So as you can see, we have a PEMDAS problem here. So we have to multiply first. 1/3 times 3/4 is 3/12. And 1/2 times 1/4 is 1/8. Again, I know I'm doing multiple steps here at once, but that's okay as long as you follow PEMDAS. So now we multiply both sides of this fraction by 3 to get 9/12. And multiply both sides of this fraction by, actually I just realized that that's not a big enough denominator. So let's multiply both sides of this fraction by 6 to get 18/24. Multiply both sides of this fraction by 2 to get 6/24. And I know that's not one of our multiplication facts, but you can still figure it out. Multiply both sides of this fraction by 3 to get 3/24. Then we have subtraction and we have addition. So PEMDAS tells us that when you have subtraction and addition, you move left to right. If you don't move left to right, you're going to get the wrong answer. If you try to add these first, then subtract that from 18/24, you're going to get the wrong answer. We have to move left to right first. Do these first. So 18/24 minus 6/24 is 12/24. And then 12/24 plus 3/24 is 15/24. Then we can reduce that fraction. We can divide both sides by 3 to get 5/8. So 5/8 of the bottle. 5/8 of the bottle is now chemical B. So I realize that was kind of a more difficult problem there. It's kind of that was unfair for me to give you that problem at the end, but it's really the same type of problem. You just have to subtract as well as add. All right, so a kitchen floor is 8.2 feet by 9.4 feet. If it costs $5 to replace 1 square foot of the floor, how much will it cost to replace the entire kitchen floor? All right, so We know it's $5 for 1 square foot. The problem is we don't know how many square feet there are. We're only given the dimensions. Now, an important thing to understand here is they don't tell us what shape this floor is. They just say it's 8.2 feet by 9.4 feet. But whenever they don't tell you the shape and they just tell you the 2 dimensions, it's always assumed to be a rectangle. That's an important point. Now, I know what you're thinking. You're thinking, well, how am I supposed to know that? Well, you know it because I just told you it. You know, sometimes these word problems, they just assume that you know certain things. So this is 8.2 here, and that will be 9.4. These dimensions are not going to be exact, so they don't have to be exact. All right. So we have the dimensions. We don't have the area inside here. That's what we need because we know it's $5 for 1 square foot. We don't know how many square feet there are. So we have to multiply these 2 numbers to find the area of a rectangle. As we talked about earlier, to find the area of a rectangle, we multiply the width and the length. So the area is 8.2 times 9.4. And we're going to have to use our algorithm for multiplying decimals. We don't have to line up the decimal. Put your placeholder. And the decimal goes here. It doesn't necessarily go straight down, but it does go there. If you don't remember where to put the decimal, then look at the previous class. Or not the previous class, but the class on multiplying decimals. All right, so we have 77.08 square feet. So now we know how many square feet we have. So it's $5 for 1 square feet. We don't have 1 square foot. We have 77.08 square feet. So we have to multiply. So 77.08 times $5. So we have $385.40. That's how much it costs. All right. So that was an area problem. Now we're going to do a volume problem. It's the same situation except instead of 2 dimensions, we're doing it 3 dimensions. 9 cubic meters of water are poured into a tank every minute. If the tank is 3.2 meters by 8 meters by 9 meters, how long will it take for the tank to be filled? So what that means is if you have, let's see, 3.2 meters, let's say this is 9 meters, and then let's say this is 3.2 meters. And then we have 8 meters. These dimensions are not going to be exactly correct, but it doesn't really matter. So that's 3.2, and then this would be, the length is 8 meters. Let me draw this out here. I guess that's fine. So we know that it's 9 cubic meters go into a tank every minute, and we're trying to figure out how many minutes it'll take to fill this thing up. So we need to figure out how many times 9 goes into whatever the volume is. Problem is we don't know what the volume is. So the previous problem was a multiplication problem. This is actually going to be a division problem. So the volume is length times width times height. We learned that. That's going to be 8 times 3.2 times 9. And PEMDAS tells us move to left to right, even though it doesn't really matter in this case because it's all multiplication. 25.2, then you take 25.6 and you multiply that by 9. And you get 230.4. So that's the volume. That's how much space is inside this what's called a rectangular prism. So if you try to put a bunch of cubes inside here that that are 1 by 1 by 1 meter, then you'll fit 230.4 cubes inside there. So that's how you measure a three-dimensional space. Now we know there's 9 cubic meters are poured every minute. So we needed to figure out how many times 9 goes into this number. So we'll do that over here, 230.4 divided by 9. Bring down a 0. 45, bring down 5, bring down the 4, and we got 6. Looks like it goes in evenly. Bring the decimal up, and we have 25. I should have known that because we had a factor of 9 here. We just get the same number we had here because we're just multiplying by 9 and then dividing by 9. 25.6, whoops, I'm sorry. The answer would be 25.6 minutes. It has nothing to do with this part over here. So that's the answer to that one. So again, you might multiply, you might divide at the very last step. John needs to install concrete to make a driveway. He needs to fill, well, why don't you try 8C, and when you're done, we'll do it together. John needs to install concrete to make a driveway. He needs to fill an 85 feet by 20 feet rectangular area. If one bag of concrete covers 10 square feet of driveway, how many bags will John need to buy? So first you need to figure out the area is length times width, 85 times 20. We can do that over here. So that would be 1,700 or 1,700. And that's square feet. And it says one bag of concrete covers 10 square feet. So we had to figure out how many times 10 goes into 1,700 square feet. So we can do that over here. And this is very interesting here. Remember this? First of all, if you're dividing this number by 10, remember we talked about dividing by 10 or multiplying by 10, or multiplying by any power of 10. If you're dividing by 10, you just take one of these zeros away. So our answer should be 170. Now notice you subtract, you get 0, then you bring down your remainder, which is 0, and 10 still doesn't go in, so you put a 0 there. Just be aware of that. A lot of students will make a mistake. They'll say the answer is 17, which is obviously ridiculous. It should be 170. So the answer is 170 bags. So if you got 170 bags, good job. All right. Leslie wants to fill her fish tank with water. If the tank measures 5 feet by 2 feet by 2 feet and water costs 9 cents per cubic foot, how much will it cost for her to fill the tank? Why don't you try 8D, and when you come back, we'll do it together. All right, we're back. So first we have to find the volume of the tank. Again, if you don't remember this formula, you do now because I just showed it to you. So volume is 10, that'll be 20 cubic feet. And so that's the total. That's the total. So we need to figure out, it's 9 cents per cubic feet, and there's 20 cubic feet. So the answer would just be 9 cents times 20 cubic feet, which is 180 cents. Now you can change that to dollars if you want. That would be $1.80, but you can probably just better leave it as cents because the problem doesn't tell you to convert. All right, so if you got 180 cents, good job. So those were area and volume problems. So now we're going to go into 9A. Now we're finding the percent of a percent. So this is actually the same thing as finding like a fraction of a fraction when you multiply. But the only difference is we're doing percent form. So instead of finding a fraction of a fraction or a decimal of a decimal, you find a percent of a percent. So this is just a type of problem that you might encounter. So when you try to find a percent of a number, you always change the percent to a decimal and then you multiply it into the number. But this time the number is a fraction itself. So change that to a decimal because we can't deal with percents. We can deal with decimals, but we can't deal with percents. You could also change that to a fraction. That would work also. But the problem is you don't want to deal with a fraction and a decimal. You want to change them all to decimals or all to fractions. And that's another thing that we could do. We could do 10 over 100. 10% means 10 out of 100. And then times that by 12 over 100 or 25 over 100. You get the same thing. But the easiest way to do it is almost always to use decimals. So 0.1, you change it to a decimal, and then to find a percent of a number, you change it to a decimal and multiply the numbers. But again, this number is an actual decimal. So all that said, all you do is just change these both to decimals and you multiply them together. So 0.1 times 0.25. You know what, I'm going to go ahead and let you do those problems on your own because they're pretty easy. You just change the percents to decimals and you multiply them, and that's all those are. We're running out of time, so we got to get to these last problems. All right, Ricky drove 60 miles per hour for 2 hours. He then increased his speed to 65 miles per hour and drove for 1 hour at this new speed. What was his average speed for the entire trip? Now, we talked about average, we talked about mean. Remember, average is just another word for mean. And if you want to find the mean or the average of a bunch of numbers, for example, 52 and 83 and 600 or whatever, if you have a bunch of numbers, you just add them all up and divide by the number of numbers. So you add all these numbers up and then divide by 4 because there's 1, 2, 3, 4 numbers. That's how you find the mean, also called the average. But in this problem, we're dealing with something completely different. The word average has many different meanings. In this case, it has a different meaning. So in this case, when we're dealing with speed, and again, this is a problem that I see this on tests, and they expect students to understand how to find the average speed without ever being taught how to find average speed. And so the reason I'm putting this problem on the test is because it's just a typical problem that students will get where they have no instruction on how to do it, but they're just expected to figure it out. This is actually a physics problem. It's not really a problem that is supposed to be focused on in a math course. For some reason, mathematicians just love to ask this type of problem because they know that students have not received a lot of instruction in physics. And it kind of annoys me because it's kind of an unfair problem. But since you see this problem so many times on tests, I'm going to go ahead and give it. And I want you to know how to do this. So here's how to do this. So we want to define the average speed. So the average speed is defined as the total distance traveled divided by the total time it takes to travel that distance. That's it. So I'm just putting a subscript T here for total. So as long as you know that, the problem is actually really easy. So we need to figure out the total distance he traveled because there's 2 stages. He's going 60 miles per hour for 2 hours, but then he changes to 65 miles per hour for 1 hour. So there's 2 stages. We need to figure out the total distance he drove for both phases. Then we need to figure out the total time that he was driving. Now that's actually pretty easy to do, and this means average speed, by the way. So that's really easy. So total distance is 60 miles per hour for 2 hours. So you do 60 times 2, and then 65 miles per hour for 1 hour. So 65 times 1. So 60 times 2 is 120. 65 times 1 is 65. Add those two up and you get 185. Now again, you can do that off to the side if you want, but we're running out of time, so I'm just doing that quickly. So 185 miles is the total distance. Now the total time is going to be the easy part. He was driving for 2 hours, then he drove for 1 hour. So 2 plus 1 is 3. That's really easy. Three hours. So now we're ready to calculate the average speed. The average speed is the total distance he traveled, 185, over the total time, which is 3. So now 185 divided by 3. Whoops. The remainder is 2. So I'm just going to leave it as a mixed number. 61 miles per hour. And the remainder is 2, and the divisor is 3. So remember, it's always divisor and a remainder for your fraction. We went over that in class 33. So 61 2/3 miles per hour. That's his average speed. Again, I know it's not fair to ask you that problem because it's kind of a physics problem. We don't talk about average speed much in class, but that's just a problem that where you have to have a definition that they didn't teach. A horse runs 5 meters per second for 6 seconds, then slows to 4 meters per second and sustains this new speed for 4 seconds. What was the horse's average speed during his full run? All right, so again, the average speed is total distance divided by total time for the both phases. So total distance is 5 meters per second times 6 plus 4 meters per second times 4, which is 30 plus 16, which is 46 meters. Then the total time, whoops, got to use the same notation here. Total time is equal to 6 seconds and 4 seconds, which is 10 seconds. And I'm glad we got 10 because whenever we divide, so total distance is 46, total time is 10. Whenever we divide, we just move the decimal one place over. So we learned that in class 33 or 34, I believe. So 4.6 meters per second is the average speed. So we don't have time to get to the other problems, but you have examples of those problems. So that's all you need to do the homework. You can look back on those 2 problems I just did, and of course, number 9, you're just multiplying decimals. Let's look at the homework. This is the homework. Get a screenshot of these 2 pages and a screenshot of these 2 pages and a screenshot of this page. So don't be discouraged. Get the problems done. They're going to be intimidating. They're going to be hard, but remember, there's only 10 problems. Learn these 10 problems and don't complain about it. I'll see you in class 36.